Let's look at how to find the equations of the asymptotes of a hyperbola. We're going to start with this one. This is a hyperbola whose center is at 0, 0, and the transverse axis, the main axis that the vertices lie on, since x is with the positive term, will lie on the x-axis. So my hyperbola center is 0, 0. For the vertices, I'm going to go along the x-axis, a distance of a to the left and the right of the center. So here's one, coordinates of that point. Well, I went to the right from 0, a distance of a, so a and 0, since we're still on the x-axis. This one we went to the left. So there are my vertices. And then I'm going to go a distance of b on the conjugate axis, the y-axis, both directions. So I'm going to have a point here at 0. I went up b from the center, and here I went down b from the center. I'm going to use those 4 points to draw a rectangle that goes through all 4 of them. My asymptotes go through the center of that rectangle and through the corners. So there's one with positive slope, and there's one with negative slope. Those are my 2 asymptotes. Now that I have those, if I want to, I can draw the graph of the hyperbola, vertex, and we're going to go out along the asymptotes. But that wasn't the question here. The question is, what are the asymptotes? What are their equations? There's lines, so they have equations. Y equals mx plus b, slope, y-intercept. Good news, I know the y-intercept. The y-intercept is 0, 0 for both of those asymptotes. They both have that point on them. So then I want to know, what are the slopes? Looking at the asymptote with positive slope over here, I have 2 points on that line. I have this center 0, 0, and I have this point up here. To get from the one to the other, what am I going to do? I'm going to go up a distance of b, and to the right, a distance of a. So for that one, let's see, my slope is change in y over change in x. I went up b and a to the right. So there's the slope. For the asymptote with negative slope, I'm going to go up a distance of b again, and this time left a distance of a. Well, left is the negative direction. So there are my 2 slopes for my 2 asymptotes. The y-intercept for each of them is 0, 0. That's enough. I can write the equations of those 2 lines. Y equals, I have one that's plus, one slope that's positive, and one slope that's negative, but the numerical values are both b over a times x, and then plus the y-intercept, but the y-intercept's 0, so I'm not going to write that. If I move the center instead of 0, 0 to being at the point h, k, my y value now has moved from 0, 0 up to h. My x value has moved from 0 to k. So those changes are going to follow into the asymptotes. I think I said that backwards. Y has moved up by k, x has moved by h. So y minus k equals, slopes are the same though. There's a positive one and a negative one. Slope is b over a. And then x minus h, those parentheses are important. So equations of the asymptotes for a hyperbola, centered at 0, 0, and centered at somewhere else, hk. What if my transverse axis is the y-axis? The y term is the positive term. Let's take a look. Here's got some axes, and we'll start with the center at 0, 0 again. This time, my vertices are going to be a distance of A on the y-axis. So I'm going to go up and down a distance of A. So I'm going to have one vertex here at 0A, and one same distance, opposite direction at 0, negative A. And I'm going to go a distance B on the conjugate axis, which is, for these ones, the x-axis. So I'm going to go over here. At that point, I went B from the center, and I'm on the x-axis, so my y-coordinate is 0. And here I went left, so negative B, 0. If I draw my framework here, I'm going to draw the rectangle through those 4 points. My asymptotes go through the center and through the corners of the rectangle. So there they are. And now we're looking for slopes. So the one with the positive slope, to get from the center to my corner point up here, I'm going to go up, this time a distance of A, and to the right a distance of B. So slope, change in y over change in x, they're both positive. For the one with the negative slope, I'm still going up a distance of A, but now left, the negative direction. So I get negative A over B. A over negative B, doesn't matter where the negative sign goes. My y-intercept for both of those lines is 0, 0 still, since that's one of the points on the line is 0, 0, one of the points on both lines, which means now my equations for a hyperbola with the y-axis as its transverse axis, y equals, I have a positive one and a negative one. Value of the slope is A over B times x plus the y-intercept, which is just 0. Again, similar to the last time, if I move the center from 0, 0 to HK, each of those lines now has a point where y has moved a distance of k. Slopes are the same though. And x has moved a distance of h. And there are my equations of asymptotes for a hyperbola with a vertical transverse axis.